Attention mechanism has been widely used in modern detection methods. The community has been drawing attention to improve the training efficiency as well as the accuracy for this type of query-based object detectors. In this work, we investigate an overlooked phenomenon where query-based object detectors mispredict at the last decoding stage while predicting correctly at an intermediate stage. We start by investigating the phenomenon. The reason causing the problem is found by rethinking the training strategy for object detection. We follow our motivation and propose a simple training strategy named Selective Query Recollection, tested on various state-of-the-art detectors and achieve significant gain on accuracy without impacting inference speed. A typical decoding stage in query-based object detectors is shown. An initial query is calculated by self-attention, cross-attention, and feed-forward network. This updated query is the output of this stage and also the input of next stage. Each stage is able to produce intermediate predictions, while only the last stage is used as final result. These stages are stacked by 1n times to gradually refine the query stage by stage. The prediction from the last stage is expected to be the optimal over the intermediate ones. However, does query-based detectors always predict the best at the last decoding stage? Surprisingly, the answer is no. As shown, the traffic light at stage 1 gets categorical confidence of 0.41, while from stage 2 to 5, the confidence gradually decreases to 0.21. The remote at stage 3 was wrongly classified as a cell phone, while from stage 3 to 6, the error was accelerated from 0.26 to 0.42. Here we present a further study. If a prediction at the last decoding stage is a true positive towards a ground truth G, we check whether prediction from earlier stages generate a better true positive to the same G that has higher IOU and higher category score than the last prediction. The rate is denoted as true positive feeding rate. If a prediction at the last decoding stage is a false positive, we check whether prior predictions produce a false positive but with lower categorical score than the last prediction. The rate is false positive E rate. So true positive feeding rate achieved 50% and 27% on the two models. False positive E rate holds looser constraints and is easier to be satisfied. Its rate is above 50% on the two models. This reveals that models frequently predict the optimum at the intermediate stage instead of the last one. This phenomenon inspires us to review the current training strategy and brings two conjectures. Firstly, the responsibility that each stage takes is unbalanced, while supervision applied to them is analogous. An early stage could make mistakes without causing too much impact because it gets chances to be corrected later, and the later stages are more responsible for the final prediction. But during training, all of these stages are supervised in an equivalent manner, and there lacks such a mechanism that places particular training emphasis on later stages. Secondly, due to the sequential structure of the decoder, an intermediate query refined by a stage, no matter whether this refinement brings positive or negative effects, will be cascaded to the following stage, while the query prior to the refinement never gets an opportunity to be propagated forward, even though it might be more representative than the refined one. So based on this concept, we desire such a training strategy that embraces two key features. First, uneven supervision applied to decoding stages that places emphasis on later ones. Second, a variety of early stages query directly introduced to later stages to mitigate the impact of cascading errors. To this end, we design a concise training strategy called as Query Recollection, QR. Compared with prior works, it collects intermediate queries at every stage and forwards them along the original pathway. Dense query recollection is the fundamental form. We densely collect every intermediate query and independently forward them to every downstream stage. After each stage, a collection is formed where the number of queries grows geometrically. In a collection, half of queries are newly generated by the current stage, while another half are from previous. Separately, for each query in the former half, we apply a Hungarian assignment and a loss calculation, so the number of supervision signal grows in geometrical progression as well. Thus, query recollection satisfies our expectancy where the number of supervision signals for each stage grows as 1, 2, 4, 8, 6, 16, and 32. Meanwhile, all prior queries would be visible in all later stages. But we didn't stop here. The last proposal empirically enhanced training, but the query collection process is indiscriminate, which brings two defects. First, the geometrical growth of the number of queries and their attention and loss calculation cost a lot. Secondly, if we input an early query that skips too many stages to a far away late stage, the potential benefit could be overshadowed by a huge learning gap between the stage and the query. So we are inclined to selectively collect intermediate queries rather than densely collect all of them. We intuitively follow an observation detailed in the paper and selectively operate collection along the basic pathway. Before starting each stage, we collect query from the two nearest stages. We name this as Selective Query Recollection, aka SQR. SQR satisfies our needs, and the number of supervision signals grows in a Fibonacci sequence. Compared to the DQR, to a great extent, SQR reduces the computing burden, and we observe that SQR even outperforms the dense counterpart in terms of precision. We conduct our experiments on COCO detection track. Table shows that DQR and SQR improve the baseline by a large margin. Note that SQR is much more efficient than DQR. Under the same training setting, SQR cuts down a great amount of training time on DQR and still achieves equal or higher AP. SQR consistently brings AP improvement to admixture, DAB DTR, and deformable DTR, improving these models by a large margin. Keep in mind that SQR is only a training strategy, so inference speed keeps as fast. So in conclusion, we investigate the interesting phenomena, analyze the cause, and propose a new training method that fits query-based object detectors. Please visit our website for more detailed information in our method.